So we have the context is the same as everyone else's. We have Mars, space, we have all of the different parts of the base. We have a lot of subsystems. I will go through all of them real quick. We have computing, dining, air circulation, safety, power, structures, comms, plumbing, laundry, hygiene, leisure, health, and sleeping quarters. We'll be focusing on dining. So this is our system fmea. The one that I figured out to be the most risky is radiation from the sun. And that's bad because it will kill you and give you radiation poisoning, which is not fun. And it's also pretty bad because it's very hard to detect that kind of thing in advance. Because radiation moves nearly at the speed of light. So, kind of hard to detect. Why is everything zoomed out? So this is the risk map. Basically, crew absorbs a high amount of radiation that causes radiation sickness, and then crew dies. So next, our subsystem is the dining subsystem. And that has a lot of parts to it as well. We have cold storage, dry storage, food prep, dishes, cooking appliances, cooking vessels, preparation surfaces, eating surfaces, seating, the cleaning station, which is the one that I focused on, utensils, and potable water dispenser. So the main function of the cleaning station is to clean food and then clean dishes and utensils. I assessed the highest risk for this one to be contamination from the Martian surface, because it's really easy to get dust everywhere, and that's not good if it gets into your food. It will make you sick. Hopefully not die, but it will make you very sick. So, and it'll be yucky. Yeah, so basically what happens is the crew, the food gets dirty, crew refuse to eat the dirty food, crew go hungry. Finally, the cleaning station specifically. This is pretty important because of just mentioned the dirty food. So it's connected to the crew, the cooking vessels and dishes and utensils that it has to clean, and it's also connected to the plumbing, power, and dining room subsystems. For that, I assessed the worst failure to be the leak, because water is a very valuable resource on Mars, and if it's just on the floor, it's not very useful like that. So that could cause a lack of water, which could lead to poor sanitation or dehydration. Yeah, so basically a bad pipe connection can cause water to leak and then temporarily be lost from the recycling system. So for my analysis, I did flow rate. So I have all these requirements, and then we're gonna have to do a test. The test is pretty fun. You just put a bucket into the cleaning station, you turn on the water, and then you time how long it takes to fill the bucket. Because of high school level math. And then I also did a leak inspection. So this is more of a preventative measure. It's an inspection procedure to check to make sure that there's just one continuous pipe used for any given fluid in the cleaning station. How do I refresh this?
Update your model,
Collaborate.
Yeah.
like you're not seeing
And
your
then
recent
update.
changes?
Yeah.
Update.
Our project,
Oh.
it's right above the commit changes to the server.
Yeah.
Yep.
That was
Okay,
perfect.
there we go.
Yeah.
To the right,
Yeah.
2 hops this time.
Yay!
Yeah, there you
Now we have next steps. All right. That wasn't finished when you opened the model. So.
Yeah, no worries.
So basically, we need to do more risk analysis, make more requirements, more VV&As, more test cases, and then I also didn't do any parametrics for this, so I'd have to do parametrics to analyze the design, and then we'd have to repeat that for all of the other subsystems and components, and then select designs for the components that meet the requirements, inspect the designs to make sure that they meet the requirements and any inspection requirements, and then analyze the design to do more requirement testing. And then you can do physical testing to do more requirement testing. So that's about it. I do have a bunch of other diagrams that I can show you guys if you want, if I have the time.
We're out of time, we would love to ask you
Okay.
questions though. I do want to commend Aaron for being the Lone Ranger on his team this semester too, so I'm really proud of you for sticking it out and getting through this without a teammate. That is definitely a big challenge that you had to face, even though I was there for you and we went through this together and helped polish it. I think it was an excellent job. My first question for you is, which component or subsystem would you focus on next around the cleaning station? And a creative choice, by the way. I thought that was awesome.
The next component.
Yeah, what would be the next critical component that we should deep dive in on this one?
I picked the path of least resistance for this, honestly. So this isn't the best. I didn't pick the best component to start with. That would probably be something else. But if I were to pick what the next easiest thing to go off of from this would be, I would probably say the heating element, the cooking surface.
Okay. Lots of human error that can be had there. We talked about fires and bad choices from humans, right?
Yeah.
So, great. Any other one?
What subsystems do you think this would interact the most with?
The plumbing subsystem.
Plumbing, yeah. Do you think electrical would also be important?
Yes, I do have it connected to electrical because depending on how the cleaning station works, it may use electricity. For example, like a dishwasher uses electricity.
Awesome.
Yes?
You said if there's a leak, then the water will be temporarily removed from like the water system?
Yeah.
How is it put back in?
How would it be put back in?
If it's temporarily removed, like do you have
evaporation. That's how it works on the ISS.
So it's evaporated and put back into the system through like the environment control?
Yes.
Cool.
Yes.
Because I know my work on plant portion of everything and being able to have like the water, which I know you most likely will need. I know you had talked about having a continuous pipe. Would you integrate like in the future possible recycling of water through plants, or I don't know.
That would be a systems of systems question.
Fair.
I don't do the plants.
There definitely needs to be like an E-Plus type of subsystem, or E-Plus team that works on both.
The idea was to take water from the plants, and the idea with the utility station was to have a pretty comprehensive integration of getting human waste to the plant as its resource and getting plant waste then to the human as its resource. Because that's how the natural cycle of life works here on Earth.
I like how it all makes sense, but it's so cool. Close loop.
You're like,
Big stuff there.
Real quick question. Have you, in your risk analysis, have you like considered anything to do with like maybe plumbing blockage?
Plumbing blockage. I did consider that. I just decided that a leak would be easier to do.
Okay.
So actually, the original one was a blockage of the drain, and then I changed it because I thought that the blockage might not be the worst thing that could happen. Depending on, like, you could just, depending on the tools you have, it's pretty easy to remove a blockage. And since I did a blockage of the drain, I thought that would be even easier to remove than a blockage of a pipe.
I have one comment, but if there's any other question. As your pseudo teammate, may I suggest that our next subsystem or component that we dig in on should be the toilet? Based on recent Artemis missions and discussions.
Yeah.
I think we talked about you doing that and I was just kind of like,
Oh.
ooh, this is going to be an interesting
Oh,
conversation. So I thought that was really cool.
Yes, I have that.
I thought you had done. I think you did that last semester in your Mars Hat.
Yes.
Yeah. And now we were talking about blockages on this, obviously too. Probably more of a concern here,
Yeah.
again, based on recent news. That would be hopefully we have redundancy. We need more than one toilet in the Mars Hat, right? Even if we got 4 people, let's have 2 toilets.
I did this last semester, so I predicted the failure
Yep.
of the toilet.
Yep, Aaron we built the Mars Hat model in our class last semester, and then he inherited it as his system of the systems this semester. Anything else for Aaron? Great job, Aaron, and high five everyone.